So this lecture is going to cover how to find the holes of a graph. All right, so that's what we'll be focusing on today. So what exactly are holes? So say for instance we have a graph. We graph some function, whatever it is, and it's going along all nicely, and then boom, oh, we have this guy right here occur. All right, so that is what is referred to as a hole in a graph. All right, so from that we could draw the assumption that this function is discontinuous. Yes, it still is a function. It would pass a vertical line test. Um, for every input, there is one output, but it is discontinuous at this point right here. All right, so it's very important that we watch out for holes in functions because whenever we're evaluating them or looking at them, trying to interpret data, etc., we need to know where the function is defined and where the function is undefined. So watch out for them holes out there. You got to watch out for them holes. So the steps in order to do so. So step number one, and just write these down. We'll talk about these in a second. You first want to factor the numerator and the denominator. So since we're talking about the numerator and denominator, we're obviously looking at rational functions. Now, step number two, we're going to find the binomials that repeat in the numerator and denominator. And the last step, number three, you will solve for x. All right, so just copy those three down. We'll talk about those in a second. All right, so if we look at an example, f of x equals x squared minus x minus 2, all divided by x minus 2. So we're going to look for the holes in this function, if there are any. First step that we need to do is see, is the numerator factored? We see that the numerator is not factored out. It's still in a standard quadratic form. So we're going to do that. So if we factor this out, all right, we're going to have x's here. And then we will have minus 2 plus 1. Now, is the denominator already factored out? Well, can't really factor it because it's linear, not quadratic. So we'll just leave it as x minus 2. All right. Step number two, we want to see if there are any binomials that repeat themselves in the numerator and the denominator. So if you notice, x minus 2 appears in the numerator as well as in the denominator. All right, so you can kind of think of this as, if we were to simplify this, we could cancel out x minus 2 from both the top and the bottom. All right, so x minus 2 repeats itself. X plus 1, on the other hand, is just in the numerator, not in the denominator, so we're not going to worry about that. Step number three, we're going to solve for x. So we have x minus 2. To solve for x, we need to set it equal to 0. Add 2 to both sides to get x equals 2. So there is a hole that occurs in the graph of this function at x equals 2. So I'm actually going to graph what this function would look like so that you can actually see that. So the scale that I'm using is going by 1. So I will not write in values there. Let's see, there would be a point here, be a point here. That is where our hole would be. Point here. So this graph would look something like this here. So notice that at x equals 2, which would be right at the dashed line, there is a hole in this function. All right, so you can check this by maybe plugging into a graphing calculator or plugging in points for yourself. All right, and you would see that it actually has a hole in this very location at x equals 2. So that is it right there, as simple as it gets. We'll do one more example problem just so you can see and have for your notes. So let's say this time h of x, remember this is just function notation. Don't be confused by it. Same thing as saying y. It's x minus 3 over x squared minus x minus 6. All right, step number one, we need to make sure the numerator and the denominator is factored. The numerator is just a binomial by itself, can't factor there. The bottom, however, is a quadratic in standard form. We'll factor this. So x squared minus x plus 6 can be factored to x minus 3 times x plus 2. Step number two, we look to see are there any binomials that repeat themselves in the numerator and the denominator. We see that x minus 3 is in the numerator as well as in the denominator. So we'll go on to step 3 and solve for x. So we take x minus 3, set it equal to 0. We'll add 3 to both sides. There is a hole at x equals 3. So I'm not going to go on to graph that and show you. You can refer back to the last example to see that, because whenever this question will be asked of me on the quiz or the exam, I will be looking for, Shirley, where is the hole located? At what x value?